Welcome. Today, we're going to pull back the curtain on something that's basically invisible magic, the computer network. It's the architecture behind pretty much everything you do online, and we're going to break down exactly how it all works.
I mean, really, have you ever just stopped and thought about it? How is this explainer traveling from a server, maybe thousands of miles away, to show up perfectly on your screen? The answer, in one word, is networking.
But to really get why networks are such a game changer, you've got to imagine a world without them. A world of, well, digital islands. Seriously, picture it. Your computer can't talk to any other computer. Every single file, every program, all your information, it's just stuck, trapped on that one machine. It's a world of complete digital isolation.
So if you wanted to share a file with a coworker, even one sitting right next to you couldn't just email it. Nope, you had to save it to a floppy disk or later a USB drive and then physically walk it over to their desk. We called it SneakerNet, and it was just so slow. It was a problem that was begging for a better solution.
And that solution, of course, was the networking revolution. It didn't just solve the problem. It completely changed how we work, play, and connect with each other.
At its core, the definition is actually super simple. A network is just two or more devices. We're talking computers, phones, printers, whatever, hooked up so they can share stuff. The entire point is to let those digital islands finally talk to each other.
And the why behind it all? It's about being way more efficient and working together. Think about it. With resource sharing, a whole office can use one single fancy printer instead of everyone needing their own. With data sharing, a huge file can go from here to Tokyo in seconds, not days. Networks don't just connect machines, they connect us, turning these isolated tools into this incredible collaborative system.
So, how does it all actually work? Well, every single network, from that little one connecting your headphones all the way up to the entire internet, is built from just three basic ingredients.
Okay, let's break this down. First, you've got the players. The technical term is nodes, but really, they're just the devices themselves. Your laptop, a server, your smart TV. Second, you need the paths, or links. These are the connections, the physical cables or the Wi-Fi signals zipping through the air. And third, and this is arguably the most important piece, you need the language.
This brings us to the real secret sauce, the protocol. Imagine you and I tried to talk, but you only spoke French and I only spoke Japanese. We'd get nowhere, right? It's just chaos. A protocol is that shared language. It's a super strict set of rules that all the devices agree to use, so data can be sent back and forth without getting all scrambled. This idea, a common language like TCP/IP, is what let the internet grow into what it is today. It's basically the grammar of our digital world.
All right, now that we have the building blocks, let's kind of zoom out and see how these networks show up at different scales, from what's in your pocket to what covers the whole planet.
Networks come in all sizes. The tiniest one is a personal area network, a PAN. That's literally the Bluetooth connection between your phone and your earbuds. A little bigger, you've got your home or office Wi-Fi. That's a local area network, or LAN. Now scale that up to connect buildings all across a city, and you have a MAN, a metropolitan area network. And when you connect networks across countries and continents, that's a wide area network, a WAN. And the internet? Well, that's the ultimate WAN.
And within all this, we've got different levels of privacy. The internet is public. It's for everybody. An intranet, though, that's private. It's built for just one organization, like a company's internal website that only employees can see. Then you've got the extranet, which is kind of a hybrid. It's a private network, but it lets specific outsiders have limited access, like a hospital letting a partner lab securely view some patient info. Okay, the theory is cool and all, but let's put it all together. Let's look at how these pieces actually work in a simple, everyday example.
So, in our little office network, you can see how it all clicks into place. We have our players, the 10 computers, the printer, and a main server. We have our paths, physical Ethernet cables plugged into desktops and Wi-Fi for the laptops. And every single device is speaking the same language, the TCP/IP protocol. And to make sure nothing gets lost, each device gets its own unique IP address, which works just like a mailing address for data.
So an employee hits save on a shared document. Instantly, their computer chops that file up into tiny pieces called packets. Each little packet gets stamped with the server's address and sent down the path. A little while later, another employee can go to that server and pull up the exact same file, and their computer perfectly puts all those little packets back together again. That's the network doing its thing.
So as we wrap this up, let's bring it right back to you. Because this stuff isn't just abstract theory. It is the very fabric of your daily life.
Just think about your day. The second you connect your phone to Wi-Fi, stream a movie, send a text, or even just listen to music on your wireless headphones, you are using a network. In today's world, you are a node, communicating across links using protocols. We live our lives inside this massive, complex web of overlapping networks.
And that leaves us with a final, kind of mind-bending thought. In a world where it's not just our computers and phones, but our cars, our homes, our whole cities are becoming nodes on one giant connected system, where does the network actually end? And where do we even begin? Something to think about.